Good morning. I decided to go through and help out a little bit with some of these free response questions. I'm just going to do one or two before I go to the conference this morning. But I'm going to look more closely at the struggles we've had later and maybe update the video just a little bit more. Hope you have a great day and I hope this is helpful. I'm going to turn off my screen right now because I'm going to be writing and you don't need this. That's not what I wanted. Uh, I'm such a goof. Man, it's been so long since I've done this. All right, here we go. So I'm going to walk you through this question the way I personally would walk through it. This is how you want to read an AP free response question and working through these things. So, to increase morale among employees, a company began a program in which one employee is randomly selected each week to receive a gift card. Okay. My immediately thought when I see that is, man, I've got some kind of success here. I am wondering if it's going to be a binomial or a geometric, right? So you want to know your conceptual things well. That just screams to me of success. Each of the company's 200 employees is equally likely to selected each week. Man, this is even stronger, right? So I've got a sample size here, and I've got the same probability here. And the same employee could be selected more than once. Okay, so they are independent results because one week does not affect the next. Oh yeah, literally it says independent. Man, immediately I'm thinking about bins. Okay, so consider the probability that a randomly selected gift card receives at least one gift card in a 52 week. So um, that we've been looking at that a couple of times. So when I look at so that's not even the full question yet. Okay, so define the random variable of interest and state how the random variable is distributed. So what I was immediately thinking is one minus probability of none, but that's part two. So when they say define the random variable of interest, right? So we've got discrete and we've got continuous, but it's not just that. When I think of discrete, I also need to consider and so when we say discrete, we would have to define maybe the mean and the standard deviation and things like that. But we also have our binomial and geometric. And I know I'm writing all this out, and you don't really have this amount of time on the AP exam, but this is me narrating my thoughts so that you can get it a little bit more clear of an idea. So I need the context. So this is the binomial random variable, which should also clarify binomial, right? Um, Remember, it's binary, independent selection. One selection does not affect the next. It's a fixed number of trials with n equals 52 and the same probability of success being one out of, was it 200 employees? Yeah. So you got a 1 out of 200 chance of winning. So it's a binomial random variable. It's not the first success. That would have been geometric. It's binomial. Binomial random variable defined by the number of times a random employee wins a gift card in a year with sample size 52 and probability of success being 1 out of 200. There's my definition of the random variable. I've got my context in there. I've got my sample size and I've got my probability of success. Remember, with a geometric, you would need context in just the probability of success because there's a variable number of trials until you get to your first success. Two, determine the probability that a particular employee receives at least one gift card in a 52-week year. And so there's two ways, the one minus probability of none. So one minus the probability that they don't win. So the probability they don't win is 199 out of 200, but we're looking at 52 weeks, right? So win, don't win. win, don't win. So remember, the idea is that they win at least one. There's only this one set of branches where they don't win. Everywhere else they'll win. And so one minus the probability that they don't win along that branch is what I'm doing in these calculations. I'm going to show you the binomial side in just a second. But I pull up my fancy calculator. 1 minus that 199 divided by 200. Really probably should have put some parentheses in there. Raised to the 52nd, not 55th, equals, I don't know what that is. Boop. Why? There we go. 0.2294. Okay. Remember, I said the other way to do this is a binomial. And so this would be, now this is going to get a little funky, but I'm going to show you two different ways to do this. So what you can do is you can just say, hey, there's, what's the formula? N choose X times the probability of success to the number of successes times the probability of failure to the number of failures. There we go. Okay, so they won at least one. So there's 52 trials. Choose one times the probability of success, which would be 1/200th, raised to the first for one success, 199 divided by 200 raised to the, I was gonna say second, but 51st for the number of failures, plus winning twice. Still 1 out of 200. As long as you have a couple of values in there, you're good to go. Now, the way you can also do this is you can use a summation formula where we do 52 choose X because the number of successes is changing divided by sum from X equals 1 to 200. I should have said that. We have not used this summation formula, so don't sweat it. But this is actually a way for those who are like, oh, that makes sense, that you can do it always. And here's what this is saying. And so that's actually taking the place of everything else. So we've already defined X as the number of successful times you get a gift card. So I'm summing this expression all the way from X equals 1 to not 200 to 52 because there's 52 trials. And so that's X equals 1, X equals 2, X equals 3, X equals 4. So that one formula is going to do that summation for me. Again, that's something that has really tripped students up when I've tried to teach in the past, so I don't anymore. But you can do it that way. If you want more information about it, let me know. If not, don't sweat it. All right, so I've got a binomial, and remember, PDF gives you individual, it's the probability density function. We want the cumulative density function. And so the number of trials is 52. The probability of success is 1 out of 200. The lower bound, we want at least one success. And upper bound is that, man, I am struggling to hit that 2. Notice exactly the same probability. So you can do it either way there. So don't forget your old rules of 1 minus probability of none when we move into new probabilities. You want those options available to you. Okay, so B, calculate and interpret the expected value for the number of gift cards a particular employee will receive in a 52-week year. So remember, when we are asked for the expected number, if you look at the formula sheet, which I probably should have made sure I already had open, it'd be surprising if I didn't. So remember, we've already defined probability, that it's a binomial random variable. So that's actually designed to help you think through things. Remember, my mean is my expected value, so there's my formula. N times P. Okay, so um, the mean of the random variable x is going to equal n times p, or just 52 trials times 1 out of 200. So 52 divided by 200. I would like a decimal. That would be 0.26, I believe. Good. Okay. So 0.26. And so now I need to interpret, I believe, right? So remember, after many, many trials of randomly selecting an employee to receive the gift card, an employee should expect to win 0.26 gift cards. And you could add that in the long run if you want. But after many, many trials of randomly selecting an employee to receive the gift card, an employee should expect to win 0.26 gift cards, right? So I've got my long run relative frequency idea. I've got the idea of an average, and I've got my context. Hopefully that's enough. Quickly on C. So as Agatha, an employee at the company, never receives a gift card for an entire 52-week year based on her experience, does she have a strong argument that the selection process was not truly random? And so, no, there is a 0.7706 chance that she never wins a gift card in a single year after many, many trials. You could also make the argument of only expect 0.26 gift cards per year or so um, in a year. And so please note that this idea is based on the work that I've already done, right? So use the previous work to your advantage. Um, let's go quickly check my rubric because I'll be honest, didn't check that yet. Probably should have. Um, let's see. Here we go. Oh, I could have just done this. Oh. Yep. So one minus probability, none. Oh, here we go. Let the random variable of interest x represent the number of gift cards. So probability, so there's my context, there's my probability of success, binomial distribution with n equals 52, probability of success being 0.005, right? So have to define the random variable as the number of gift cards a particular employee receives in a 52-week year. I think I had that context. N equals 52 and p equals 0.005. Oh, So yeah, I had those two things, and then I got the correct probability. Do you notice with the probability, you have to have the correct direction for the event? And so I had both of those in those situations. Okay. For part B, ooh, there's a lot. Notice there's that summation notation that I used earlier. We haven't talked about that detail yet, so I'm going to skip that. Expected value. So if the random process of selecting one employee each week to receive a gift card is repeated for a very large number of years, each employee can expect to receive about 0.26 gift cards on average. Ooh, I wonder if I needed that. Got my expected value, correct supporting work, provides a reasonable interpretation. So I need a repeated selection over a long period of time. The concept of an average or a mean. I think we expect to see this, right? Covers that idea, but maybe you want to make sure you include that word of average and then context, right? It's all about context. And there it is, right? You could argue that C, I believe, off of mean as well. Yep. So you could examples that satisfy component two, the expected value computed in part B. So lots of ways to justify it. All right, I got time for maybe one more, and then I need to go to this conference. For a simple random sample of, so I'm wondering if I want to do three or four. I think three typically shows a little bit more trouble. I'll get to four eventually. Okay. Company can obtain a list of all individuals who, let me start at the beginning. An automobile company wants to learn about customer satisfaction among the owners of five specific car models. Large sales volumes have been recorded for three of the models, but the other two models were recently introduced. So their sale volumes are smaller. And that's why we're seeing these smaller numbers here. The number of new cars sold in the last 6 months is shown below. All right. So we want to sample 2,000 owners, but there's 297,000 or so that have been bought. So for a simple random sample, or for simple random samples of 2,000 new car owners, what is the expected number of owners of Model E and the standard deviation of the number of owners of Model E? See, this is an interesting one because it looks like a probability distribution-ish, but it's not. Notice we have Model E, so we could treat that as a success or not a success and standard deviation. So when I'm looking at A, I'm actually now thinking about, and the other thing for me, right, is there's no value and then a probability. It's the car model and then the frequency, but I can also make a relative frequency here. So let's treat this as binomial with a success, probability of success being 2,323 out of 297,354. And then my number of trials being 2,000, the mean of X is equal to just N times P. So let's grab our calculator. So that would be a pain. N times, no, yep, times 2,000. I should remember this. Why do I make my life hard sometimes? 2,323 divided by 297,354. So my mean is simply 15.62 Model E's. And then my standard deviation formula, now see, this is one I always have to go back to. I think it's square root of n times p times 1 minus p. Yep, there she is. Be the square root of 200, nope, 2,000 times 2323 divided by 297,354. And I could do the calculations, but forget that. I'm just going to use the idea of the complement and put it in exactly that way. Do you notice I've got supporting work here? You have to have that for the AP exam. And so the standard deviation would be 3.94 cars. Um, Notice it does not ask for an interpretation, so I'm stopping there. When selecting a simple random sample of 2,000 new car owners, how likely is it that fewer than 12 owners would be included in the sample? I didn't intend to do two binomials, but here we are. Um, that fewer than 12. So this is the probability that my random variable x is less than or equal to, or is it just less than? Fewer than 12, so fewer, less than, would equal. And so again, this is where I'm going to use that formula. Um, So 2000 is my number of trials. Choose zero successes times 2323 divided by 297, 354 to the zero successes times 1 minus raised to the 2000. And I'm just going to use ellipses to my advantage. I don't continue because forever. So I stop it at 2000, choose 12 times 2323, 297, 354 to the 12th, 2323 divided by 297, 354. Man, I tell you what, this is getting monotonous. And then 2000 minus 12 is 1988. And so remember, you just have to be able to recognize it. You got to be able to set it up. And then calculators got some fancy stuff for me. Binomial CDF. Number of trials is, nope, 2000. Probability of success is the 2323 divided by 297. And by the way, I could have gotten a decimal by now, and I kind of regret not, but notice my lower bound is 0, my upper bound is 12. I hit enter, and there's my probability that fewer than 12 are selected. Okay. Notice it says justify, so I've got some work there. C says the company is concerned that a random sample of 2,000 owners would include fewer than 12 owners of Model D or fewer than 12 owners of Model E. Briefly describe the sampling method for random selecting 2,000 owners that will ensure at least 12 owners will be selected for each of the 5 car models. So C, I'm going to do a stratified random sample. This is the only way that I guarantee that I get some from each of the car owners, and where now to me it just sounds like they want me to describe it. They don't want me to go into deep detail. So you could do a stratified random sampling where n equals 400 is selected. Um, let's do where each stratum is a car model. And n equals 400 cars are randomly selected from each model. Now, I will say this is not the one that I would go with, but this does guarantee that we get at least 12 from each. What I would really do is I would randomly select from each stratum um, a proportional number of cars. So I proportionally represent each car model. Notice that would give me, say, 15 cars. And I would go into more detail on the actual thing, but 15 or 16 cars for Model E, etc. So let's see what the rubric said, because I really do have to get to this conference at this point. And as I said, I will do some more later. So both of these are binomial, but make sure you look for geometric. Make sure you look for other things like that. So 0.147, is that what I got? I don't remember that. I did not. Oh, that's because I went to 12 like a dingus. I even said less than 12. Sorry, guys. That was oof, big oof. Let's try that one again. Yeah, 0.1457 is correct. Sorry about that. Mistakes happen when you're rushing, right? Um, so yeah. Okay. I missed the average. There we go. Oh, 15.62. Man, I was looking at all these numbers. I was like, I don't see it, but there it is. And then square root of 15.5, 30.94 is what I got. All right, C, stratified random sampling. Yeah, so we don't have to, apparently I should have identified the sample sizes that I would expect to do. Let's see. So you notice you had to recognize for B the applicability of the binomial distribution, which I did. Identifies the correct parameters, right? So I identified P, I identified N just by setting up the equation. So I've satisfied all these things. Um, and those are the other options, okay? C, essentially correct if the response describes an appropriate sampling method, it had to be stratified. Total sample size of 2,000, at least 12 owners of each. Um, Yeah, so because the 400 of each would have worked, because that's all the requirements they had. But again, I would have done it proportionally identifying how many of each, and it adds up to 2,000. Okay, hope that was helpful. I got to go. Y'all are fantastic. Keep crushing it, keep learning, keep growing, and I will see you soon. Bye.